Hello! The topic for today's video is the discovery of proton and neutron. We have studied in the previous videos about the discovery of an atom and then how J.J. Thomson discovered the presence of a subatomic particle that was an electron by carrying out the cathode ray tube experiment, that is the discharge tube experiment. Now Goldstein in 1919 carried out a similar experiment, and this time he wanted to find out, he knew that if there are negatively charged particles present in an atom, there should be an equal amount of positive charge. And to establish that, he modified the cathode ray tube by switching the electrodes. That is, this became now the anode and this was the cathode. And this time it was the cathode which had a hole in it. So when he passed high voltage electric current through a gas like hydrogen in the cathode ray, that is the discharge tube, he found that simultaneously, when you would expect the cathode rays to be produced, at the same time a ray was being shot out by the anode towards the cathode, and since the cathode had a hole in it, this ray just shot across it and went forward and illuminated a fluorescent screen on the other end. Now that he discovered that this ray was traveling from the anode towards the negative cathode, this should have been positively charged. So how did he prove it? He took an electric field, just as J.J. Thomson did, and in the presence of the electric field, this ray, it deviated towards the negative charge, which meant that it was positively charged. Similarly, when he took the magnetic field, he found that it again behaved like a positively charged ray. But there was a difference between the cathode rays and the anode rays. The cathode rays were always electrons, free electrons, and the particles of the cathode ray were all identical. But anode rays were made up of by the ionization of the gas present in the discharge tube. That is, if it was hydrogen, hydrogen has one proton and one electron. When one electron is given out and it acts as the cathode ray, what you are left with is the remaining, that is the ion of hydrogen, which consists of one proton, and therefore it would have a mass of one proton itself. But if you took helium, then helium would shoot out two electrons. The two electrons would form the cathode ray and they would be identical. But the nucleus of helium has a mass of 4 instead of having a mass of 1 proton. So the properties of the anode rays depended on the nature of the gas that was taken. Alright, but by similar methods, he found out that the charge of the proton should be equal to the charge of an electron, only it was positive charge. That is, the charge of an electron is 1.6 into 10 to the power minus 19 coulombs. This is the same charge of a proton, but it is positive charge. The charge over mass ratio was also calculated by the same method as adopted earlier in the Millikan's oil drop, by J.J. Thomson. And this was found to be 9.58 into 10 to the power 7 coulombs per kg. So from these two values, he calculated the mass of a proton, which came to be equal to charge over mass was equal to this amount, and he got the value of 1.67 into 10 to the power minus 27 kgs was the mass of a proton. So that is how in 1919 Goldstein discovered the presence of protons, and he found out about the properties of protons and its charge and mass. For a few years, scientists still were a little confused about atoms. Although they had found electrons and protons, there were still things that were confusing them. Chadwick in 1932, he said that if we take an atom of helium, helium has, by now we had calculated the number of protons in different elements. So he said that helium has 2 protons and hydrogen atom has only 1 proton. So he said logically, if we take 2 hydrogen atoms, they should weigh equal to 1 atom of helium. So he took 2 atoms of hydrogen and he found out the weight, and he found that despite there being 2 protons on this side and 2 protons on this side, helium still was heavier than 2 atoms of hydrogen. Rather, he realized that when you have 4 atoms of hydrogen, that mass becomes equal to the mass of helium. Which means that although helium has 2 protons only, there is something else present in the atom of helium which is contributing to its mass, and it is not positively charged, it's not negatively charged, because we've already studied about the properties of electrons and protons. Now, to establish the presence of a third particle, he carried out an experiment. This was somewhat like the Rutherford's experiment. What did he do? He shot alpha particles to a sheet. And what were these alpha particles? Alpha particles are nothing but a helium nucleus. When you have helium which has 2 protons and 2 electrons, if you remove the 2 electrons from the helium nucleus, you are left with, from the helium atom, you are left with the helium ion. This helium ion is when there were only 2 electrons, so they are shot out, you are left with only the helium ions. The helium ion is 2 positive charge and has a mass of 4. So when he bombarded the alpha particles, the alpha rays, over these 3 elements, that was lithium, beryllium and boron, mind it again, he knew that lithium has only 3 protons, but it has 7 AMU, its mass is 7 AMU. Beryllium has only 4 protons, so it should weigh 4 AMU, but it weighs 9 AMU. Boron similarly has 5 protons, should weigh 5 AMU, but weighs 11 AMU. So when he bombarded these with alpha particles, he found that certain radiations were released, they were shot out of these elements. And these radiations, they consisted of particles which had mass, but they did not have charge. They had mass, but they did not have charge. When he bombarded these and he brought them to paraffin, he got a sheet of paraffin and he allowed these rays, whatever was being radiated, to come and hit the paraffin. When it did that, it was as if a billiards ball, a ball hits another ball and it shoots it with so much force that it pushes it further, and protons were released from the paraffin. If protons were released from the paraffin, whatever this radiation was, it consisted of particles which were in mass and size, they should have been equal to a proton. To hit it and shoot it out of the atom, it wouldn't have been, if it was a smaller particle like an electron, it wouldn't have been possible to push out the proton like that. So he decided that whatever this particle is, and which is neutral, he called it the neutron. And he said that neutrons are particles which have a mass which may be equal to that of a proton, and that is why it was possible for them to hit the proton and throw them out of the paraffin. So that is how neutrons were discovered by Chadwick. So now we knew that an atom consisted of subatomic particles, which were protons, electrons and neutrons. And Thomson's plum pudding model, which I explained in the previous video, became obsolete. It made no sense. We now knew they were these particles, but how were they arranged in an atom? What was the atom actually like? This was later established and discovered and found by various techniques, by different experiments. And today we have the quantum mechanical model of an atom, which tells us what an atom is like. In the next video, we'll study about the Rutherford's experiment to learn more about the story of how the structure of atom was decided on. Thank you for watching.